Good afternoon, microeconomics students. This is Professor Lewis here. I am doing one other video besides oligopoly for Unit 2 because we had some people that were absent the day that we covered how to solve the short-run graphs for those different businesses, and so this is to help them. I'm not going to do the solution for all the short-run graphs in the practice problem set. I'm going to do just the first three. And so we're going to be sharing the screen one more time here, and so give me a moment to get this thing all put together. What we're going to be doing here is we're going to be going through how do you solve each of these graphs step by bloody step. That's the whole idea here. Now, one of the things we went over in class previously was we talked about the fact that you have to look at the demand curve to answer the major questions. The first question is, which market structure is the firm producing under? And this has to deal with how steep or flat the demand curve is. This also kicks back to the Unit 1 test, problem 5. If you look at this demand curve here for G1, you'll notice it has a shallow negative slope. That's not a monopoly. They have a steep negative slope. That's not perfect competition. They have a horizontal demand. So question A here is monopolistic competition, but you have to explain why. It's monopolistic competition, and I'm using some abbreviations you're allowed to use. These will be handwritten by you, of course. B/C for because. Demand has a shallow negative slope. Okay. Question B asks, does this business produce or shut down the short run? Well, the short run shutdown rule says that you compare P star to minimum average variable cost. And if the price is strictly less than minimum average variable cost, the firm shuts down. If the price is greater than or equal, you produce. Now, there's only one curve that provides prices. Does anybody remember what that is? It's the demand curve. Prices are going to be read off the demand curve. Now, although price is variable, we still have to compare price to the average variable cost curve by comparing the altitude or the height of the demand relative to average variable cost. If demand has a tangent point or intersects and cuts above average variable cost, you've got quantities where price is bigger than minimum average variable cost, and so it's better to produce. But if the demand curve is always below the average variable cost, you're going to lose more money by producing. It's better to shut down. So if you look at this demand curve, you notice here going top to bottom, I'm always hitting average variable costs first, going on these straight lines vertically. The demand curve is always below the average variable cost, so this means it's better to shut down. So shuts down because D is below average variable cost. I'm using initials for those for all quantities, every last one. Now part C, we worked on this with our table problem. Anybody remember what happens when the firm shuts down when it comes to a profit or a loss? Well, the firm produces no output, but it still has to pay costs. Since the quantity of output sold is 0 units, the total revenue is $0.00, but the total cost is equal to the fixed costs. So we're going to have an economic loss. We know this immediately when the firm shuts down, so it's because B/C, firm shuts down. All righty, now for part D, there's going to be no areas to show. And there's a reason for that, okay? When the firm shuts down, you have the following situation. Q star is equal to 0 units. That's a point. A point has no dimensions and therefore no area, no length. Total revenue is equal to $0.00, which should also be a point, no dimensions. Total cost would equal a fixed cost, but do you see any fixed costs in this graph? We've got average variable, average total, and marginal cost. Demand, which has price and marginal revenue, but there's no fixed costs on here. We have nothing to show area-wise. We have to say why. No areas to show as Q star is equal to what when the firm shuts down? 0 units. Total revenue is equal to P star times 0 units equal to $0.00. Total cost is equal to the fixed cost and, economic losses. I need to borrow a Greek symbol here for 1 second. One of our little deals I'm typing here is called symbol. So I'm going to go ahead and find that real quick. There we go, symbol. And then we're going to say negative pi equals, and then we go back to Calibri. Okay, pardon the font changes here. I got to do this here. Okay, Calibri. And then I got to go red. FC is a dollar value, so it's red ink round parentheses. That means that the economic losses are a negative cash value that matches fixed costs. Now, we're going to talk about long run in this one case only. When a firm shuts down, here's the situation. They are losing so much money, they're not producing anything. They're not earning any revenue, but they're having to eat their fixed costs. After a while, you know what entrepreneurs are going to say? This is crap. This is garbage. I'm not going to keep doing this here. Why keep throwing money away when you can't sell anything? Now, I realize there may be a few firms that have a lot of money from the owner and they can still survive being shut down a long time, but most business owners don't want to throw away money. I deal with what's typical. 95% of the time, there's going to be no long run graph. LR is for long run, because firm is likely to exit the market in the long run. I want you to notice we have no geometry here, but we have to explain why. We have no long run graph. We have to explain why. Long run graphs are being handled in class, okay? But the thing is, that's everything for graph G1. And the thing is, if we had a perfect competition graph where the firm shut down the short run, other than the fact that the demand would be horizontal, we'd have similar results written here. And that's how you always handle a shutdown case. Now let's take a look at graph G2. Graph G2 is a little bit different here. First things first, question A, which market structure is the firm producing under? That demand curve is horizontal. That demand curve is sitting on the marginal revenue. Only one market structure has a horizontal demand curve. Which one is it? Problem 5, test 1. That is perfect competition. Only perfect competition will have a horizontal demand curve. So because D for demand is horizontal. Question B, producer shut down the short run. Remember, only demand provides price. And in fact, we got that P star from the equilibrium right there. It's constant for this business. I want you to take a notice where my pointer is. Demand is intersecting average variable cost at least once, in fact, twice. But in between, you notice there's a lot of values there. There's a lot of values where price is above average variable cost. So this firm is better producing than shutting down. So produce, and part B, because D above average variable cost for some quantities. Doesn't have to be for all, just for some. Now, remember on that table problem, we were comparing price to average total cost to determine if we should expect a profit or a loss. Well, the demand curve here has our price, and here's average total cost. I want you to take a look at that average total cost. I want you to take a look at the demand curve. Does this demand curve touch average total cost? No, it doesn't. Is this demand curve ever in the space above some values of average total cost? No, it isn't. This demand curve is always below average total cost. So since price is always less than average total cost, it's producing, but it's going to be an economic loss because demand is below average total cost for all quantities, not just some. Now for part D, we're going to have to do some geometry here. Remember what happens when the business produces. When the business produces, what ends up happening is the following. It is going to produce quantity Q star at price P star corresponding to MR being equal to MC. Remember, demand and MR sit on top of each other. So here's marginal revenue and here's marginal cost. On a graph, MR is equal to MC where the two curves intersect each other. Now, here's how we're going to find the right-hand side boundary, which will help us locate price, so this one's already given to us, and the average total cost to do some geometry here. First things first, I'm going to create this vertical line here. I'm going to adjust the length in just a minute. I'm also going to adjust how wide it is. That's a little bit too thick. That's a little bit too thin. That one's okay. So I'm going to move this line here. Whoops, that's a spline. I don't want a spline. I want a straight line. So let's do this again here. I'm going to create this vertical line, and then I'm going to move it to where it's passing through MR is equal to MC. Now, that's to the right of it. That's where MC is equal to average total cost. That's to the left of it. Here's where MR is equal to MC, right there. And I'm going to shorten it so that it doesn't go above the highest curve above it. And you know what? I think I may make this thinner here because it's kind of hard to see the corners there. Okay. If you take a good look here, let's zoom in for a moment, then we'll zoom out. You will notice here that MR is equal to MC right here, and that's where that line is, okay? And you notice that above it is the average total cost curve. That's the highest curve above it. And then we go all the way down, there's quantity axis, which is where it ends. Now I need to create some other items that I can put in here because I have to put some corners here. We've already got P star located, so I do not need that, okay? But what I do need, however, is I need to have a Q star for the optimal quantity. I need to have the letter C, and I need two corners, A and B. And I need to also be able to say ATC at Q star equals. Say what? Trust me, it'll become a little more apparent in a minute. First of all, let's talk about locating Q star. Let's make sure our selection is transparent. That's important. Okay. I'm going to grab this Q star. I'm going to move it over to here. Notice Q star is now directly below MR intersecting MC. Corner A is always used to find the price. And which curve has the price? If you said demand, you're correct. So corner A is where that demand curve is crossing the blue line. P star is already found to our left, so we don't have to locate it. That's what's nice about perfect competition. But we now have to find one more thing, and that is corner B. Corner B is always on the average total cost curve directly above Q star. Corner A is used to find P star. Corner A is always on demand. Corner B is used to find average total cost for Q star. Corner B is always on the average total cost curve. A, B, and Q star are all on the same line segment. Make sure they're lined up nicely when you do this, and make sure you use a blue pen or pencil. Now, this letter C is a dollar value. It's the dollar value for the average total cost at quantity Q star. The reason why we're using that letter C here is because it represents average total cost at Q star. We're not producing 0 units, so our average total cost is non-zero. The thing is, average total cost equals total cost divided by quantity. And since we have to represent this as the area of a rectangle, and the area of a rectangle is length times width, average total cost times quantity will equal to total cost. And so I'm going to go over here to corner B, and I'm going to create a horizontal blue line. I'm going to adjust it just a little bit here until it gets to be easily visible. And I want you to notice that I've gone straight horizontal left from corner B to the dollar axis. And excuse me, I did not mean to make that one there. And this is going to be the average total cost at quantity Q star. It's this mark right here. Okay, and that's what letter C stands for. All right, zooming back out now. Okay, we need to answer question D using geometry. So I'm going to start by saying total revenue. Total revenue is equal to price times quantity. Excuse me. P star times Q star. The length of the segment from 0 to P star is price. The length of the segment from 0 to Q star is quantity. And so the area of this rectangle, we start lower left and go clockwise, excuse me, from 0 up to P star, over to A and down to Q star. That big rectangle on the bottom is going to equal to total revenue. So we write area, and I don't have a rectangle symbol, I don't think. Let me see if I can come up with one, though. Probably not, but you never really know. You know what? I don't want to mess with this here. I'm just going to write the word rectangle. You can use a rectangle symbol that looks like a rectangle if you like. From 0 to corner P star, to corner A, to corner Q star, that's equal to total revenue. Total cost is equal to average total cost times quantity, which is C times Q star. Okay, C times Q star. I don't have a multiplication symbol here. I'm just going to throw an X in here just for now. I don't like the use of X. It should be the algebra one, not the one from arithmetic. The length of the segment from the origin to letter C, that length is equal to C, the average total cost for Q star. The length of the segment from 0 to Q star, that length is Q star. So starting at 0, the area of the rectangle from 0 to C to B to Q star is average total cost times quantity and is therefore total cost. Area rectangle 0, C, B, Q star. Now, I want you to notice 0, C, B, Q star total cost is slightly bigger than 0, P star, A, Q star total revenue. And notice we've got a skinny little rectangle in between where I'm moving my pointer. That skinny little rectangle in between is the degree to which total cost is bigger than total revenue. That is our economic losses, and we're not going to use red here because this is not cash. This is areas. Areas can't be negative, but we're going to be using our symbols here and so forth just so that we're consistent. But the thing is, we're not using any red ink. We don't have numbers. We don't have cash. So we're going to do this just strictly as an area. The magnitude of that area matches the economic loss. That's TR minus TC with a negative result. That's the area of the rectangle. The lower left-hand corner, that skinny little rectangle, is P star. Excuse me, let me adjust my spacing here. The next one is C. And then going to the right is B. Remember, we're going clockwise, same direction the clock goes, remember? And then A is the lower right-hand corner. So the skinny little rectangular area, that is equal to the total, probably the economic losses to the firm. Now, that's all for part D. Because this firm is producing in the short run, it will have a long run graph. And the long run graph for this one would be the same as the long run graph for a perfect competition business that produces in the short run at a profit. They're going to end up with the same situation because of long run adjustments to the market. Now, I'm going to also say that we could have had a situation with a monopolistic competition firm producing in the short run at a profit or a loss. And again, as long as the firm produces in the short run, it will have a long run graph. The long run outcome for monopolistic competition, whether produce at a profit or produce at a loss, will be the same. But for any firm that shuts down the short run, the long run result is there is no long run graph. That business is likely to exit the market. G2, that firm will have a long run graph. It is not likely to exit the market. Now let's move on and talk about G3. G3 is very interesting here. Now, the first question is, which market structure is this business producing under? Well, take a look at the demand curve. The demand curve has a steep negative slope, which means that it's a monopoly. But do we see a P-reg labeled on here anyway? If there was a regulated monopoly, there'd be like a P-reg going to the demand curve to the dollar axis on a horizontal line. I don't see it, do you? Well, of course not. This is not a regulated monopoly. There is no P-reg. So this is a pure monopoly. And we need to say why here. Because D has a steep negative slope and no P-reg, no regulated price is present. Now, question B, does this firm produce or shut down in the short run? Take a look at the demand curve. Here it is with a D. Take a look at the average variable cost with the AVC on the end. Notice demand intersects average variable cost and it goes above it. As long as demand at least touches average variable cost or intersection goes above it, the firm is better off producing than shutting down. So produce in short run because D is above average variable cost, short run shutdown rule application for some quantities. Okay, question C. Economic profit or economic loss. We compare price to average total cost. Only demand provides prices. I repeat, only demand provides prices. I want you all to notice, here's average total cost. Demand and average total cost intersect each other. To the left of that intersection point, the demand is clearly a lot higher than the average total cost, which means there are prices at which this business can sell products where the price per unit is higher than the average total cost per unit. That tells you a profit is possible. So economic profit because D is above average total cost for some quantities. And then part B, which we're about to get to, I'm going to actually put that in just a second here. That's going to be our geometry problem. This is not a regulated monopoly. They have a different rule than everybody else has. This is a pure monopoly. And so just like any other structure, if the firm produces, this one does, you choose Q star and P star corresponding to MR being equal to MC. Here's marginal cost. Here's marginal revenue. They're equal to each other at this point of intersection. And so what we're going to do is we're going to construct a vertical line that's going to start at the highest curve above that intersection. And this time that's the demand curve. And that's going to pass through MR equal to MC. And I think I just about got it lined up. I'm just moving a little bit to the left. There we go. And let me make it a little bit thicker here because I'm not zoomed in like I was before. MR equals MC is what we use to find the line. You would take your protractor straight edge and you would set it so that it's perpendicular to the quantity axis. The horizontal axis is called Q for quantity. And it goes from the highest curve above it, which this time is demand, passes through MR intersecting MC and stops at the quantity axis. All righty. This is our right-hand side boundary for our rectangles. Now, P star has to be located this time. Q star has to be located as well. Okay. We also need to find corner A. We need to find corner B. We need to find value C. And value C is equal to average total cost, average total cost at Q star, which is equal to value C. All righty. So I need to have these ready to go. Q star is found where MR is equal to MC. Where do I put this Q star? Does it go here? Does it go there? Does it go over here? No, silly. It goes on the quantity axis directly below M equal MC. That's your optimal profit maximizing, in other words, quantity. Corner A is used to find P star. Which graph has P star? Only one graph has prices. That is the demand curve. Corner A is where the blue line crosses demand. So to find P star, we do our straight line. You do a horizontal line going from corner A on the demand curve, that blue line crosses it above Q star, and then go to the dollar axis and stop at the dollar axis. The vertical axis is dollars. Prices aren't the only thing measured in dollars, y'all. So are costs. Remember, that's why we call it the dollar axis, or vertical if you prefer. So there's P star. We now have our rectangle for total revenue. What's the next thing we need to find? We need to express total cost as a product of two numbers. It's going to be what times quantity. That's right. It's going to be the average total cost times the quantity. That's a dollar value, but we need a reference corner to find it, and that is reference corner B. A, B, and Q star are collinear. Corner B is where the blue line crosses average total cost. Corner A is where the blue line intersects demand. All right. And so before I actually can move this, I need to go right. I have to go from corner B horizontally to the left to the dollar axis. Okay. That is average total cost at Q star, okay, which is equal to C. Letter C equals average total cost at quantity Q star. Now that the architecture is in place, we can talk rectangles once again. Rectangles. Okay, so let me just get this thing kind of set up just so here. Part D, total revenue is equal to P star times Q star. Length of the segment from 0 to P star is price. Length of the segment from 0 to Q star is quantity. It forms a rectangle starting at the origin, going up to P star, over to A, and down to Q star. Everybody has to do this clockwise from the lower left-hand corner. That's the area of rectangle 0, P star, A, Q star. And remember, go clockwise, same direction the clock goes. Total cost is equal to average total cost times quantity, which is C times Q star. Notice here that C is not as high up as it was in that last graph here, because average total cost is less than price, since we're making a profit. The length of the segment from 0 to C is average total cost. 0 to Q star is total cost, is quantity, pardon me. So area rectangle 0, C, B, Q star, this rectangle on the bottom, okay. That's equal to the total cost. Notice this big rectangle's area is total revenue. Notice this smaller rectangle at the bottom is total cost. The difference between the two of them is this smaller rectangle at the top. This rectangular area is how much total revenue is bigger than total cost. That's our economic profit. So I need to change my font just one time more here. And we're to use symbol. Yep, got to use symbol here because that's where those pi's are found. Pi, excuse me, equals. And we're going to go back to Calibri. TR minus TC. Lower left-hand corner is letter C, and we go clockwise up here. Area, rectangle, C, P star, A, pardon me, AB. All righty. So that's the answer to section D, and now we've got all the short run stuff done. But let me make a couple of comments here. You're not going to see a pure monopoly producing in the short run at a loss or shutting down for a loss. Those are examples of what you call tax evasion and a scam. They're not legitimate. A pure monopoly will be producing in the short run at an economic profit, and that's the only way the pure monopoly is going to work. The others are facetious. Yes, they're possible, but they're not likely. Less than 1% chance of that really happening, and we're going to deal with the real world exclusively here. All righty. The thing is, regulated monopolies have a different rule, but they'll also be producing in the short run at an economic profit, but it won't have the same boundaries because they lose their control over their price. This P star, man, that's kind of big there, okay? And that Q star leads to a bigger profit. If they produced at a lower price, that rectangle will be flat, they'd have more output, but as that rectangle flattens, that area gets smaller. This is the maximum profit possible. If they produced at a higher price versus the output, the rectangle would get skinnier and the area would shrink again. So this is the best size for it to be, given the configuration of these graphs. Any graph that produces in the short run will have a long run graph. And so I'm going to scroll back up. We take a look at what we had here in each case and so forth. And these are just examples here. But again, Question A, question B, question C are all based on demand curve. Slant or tilt of the demand curve, and with a monopoly, is there a P-reg present or absent? Position of demand versus average variable cost to determine produce or shut down. Position of demand versus average total cost. Average variables for shut down or produce. Average total is for profit or loss when we produce. Of course, if we know we're shutting down, we immediately know it's an economic loss. There's no debate or discussion when that goes down. Okay? And then everything we did here to find P star, Q star was based upon the intersection of MR and MC. And then finding a right-hand side boundary that starts at the highest curve above it, again, only when we produce, passes through a marked MC, and stops at the quantity axis. And that's how we solve these things. All righty. So we're going to go back over here and stop sharing the screen here, and we'll wrap this thing up. Didn't mean for this to go so long, but at the same time, because of people being absent, this is going to be useful. It's not all the answers to all the problems in that practice problem set, but it's a good way to get started. Slideshow number 4 and slideshow number 5 have the optimization rules for regulated monopolies. Make sure you study them. They're not the same as pure because, again, they lose price control. And also slideshow number 5 does have the long run graphs where applicable. So good luck to everybody. Success to y'all, and I'll see y'all later.